The second pillar of the credibility revolution is critical appraisal. And so this is the second pillar after transparency. And as we mentioned before, transparency is crucial and necessary, but not enough. And this is expressed best, I think, in Andrew Gelman's quote from his paper, Honesty and Transparency Are Not Enough, where he says, consider the practical consequences for a researcher who eagerly accepts the message of the ethical and practical values of sharing and openness, but does not learn about the importance of data quality. He or she could then just be driving very carefully and very efficiently into a brick wall, conducting transparent experiment after transparent experiment, and continuing to produce and publish noise. So this is true for the individual, but it's also true for an entire field. If a field adopts transparency, the value of transparency, but not of critical appraisal, of making sure things are high quality, that when we make errors, we correct them and then try not to make them again, then we'll just be doing really transparent work that's not very good. So in addition to all the transparency reforms that I talked about, we also have been working on reforms to increase the amount of engagement and verification and correction that we have with the work in our field. So I'll go through a few of these today. So one that might be a little bit surprising is the role of strong theory in critical appraisal. And this is because theory provides one way to gauge if we're accumulating knowledge, if we're making progress. And for that to work, our theories need to be very strong and very clear, because if a theory is weak and vague, then almost anything can be incorporated into that theory, and we won't be able to tell when we've made some missteps, when our theory has been going down the wrong path, if a theory is so vague that it can accommodate any finding. And this is a problem for a lot of social sciences because we deal with really complicated things. This was expressed in another Andrew Gelman quote, where he was quoting a sociologist, Jeremy Fries, who said that theories are so flexible that just about any comparison can be taken to be consistent with theory. Remember sociologist Jeremy Fries' characterization of some hypotheses as, quote, more vampirical than empirical, unable to be killed by mere evidence. So as we mature as a field, we should be developing stronger and stronger theories that make more and more precise predictions so that fewer and fewer things are consistent with those theories so that we can falsify them, we can throw out bad ones, make progress, and accumulate knowledge. Another much more simple and clear-cut way of doing critical appraisal is just to look for errors. And there are new tools being developed constantly to help us with this. Some of them are extremely basic. So for example, one of them called StatCheck is literally just a tool that scrapes APA-style statistics reported in papers. So any statistic that's reported in APA style with, for example, a t-value with degrees of freedom, the t-value and the p-value, it scrapes those and checks the internal consistency automatically. So it checks, does the reported degrees of freedom and t-value match up to the reported p-value? Is it even plausible? Is it even coherent? It doesn't mean it's right. The authors could have done the wrong statistical test, but at least the values match each other. And so the creators of StatCheck actually went through and scraped a bunch of articles from psychology journals published between 1985 and 2013 and ran them through StatCheck to see how many articles had at least one error. And most of these errors are relatively trivial, like the second decimal place is off or something like that. So they also looked how many had what they call a gross inconsistency, which is when the reported statistic is reported as significant, but actually the calculated t-value and degrees of freedom should not be significant, or vice versa, if it's reported as not significant, but actually it should be. So in the results of this, this scraping project, found that about half of all published articles in this data set in the 8 major psychology journals over 20 some years showed at least one error, and 13%, or about 1 in 8, had a gross inconsistency. So reported a result as statistically significant when it shouldn't have been, or vice versa. So it's good that this tool exists, and now more and more journals are incorporating it before publication so that these errors get caught before the article gets published. And in general, it would be good if we had more error detection and correction before publication. And so one tool to do that is one that I mentioned earlier, registered reports. So registered reports is a type of paper that some journals are accepting, where the authors submit the paper before they've collected the data. So what happens is the authors develop an idea, they design a study, they write up the intro method, what they plan to analyze, and submit that manuscript to a journal, and it goes out for peer review. And if the reviewers and editor ultimately decides that this is a good project, it should be run, then the editor has to make a decision to accept the manuscript what's called an in-principle acceptance. That means regardless of what happens after that, of the data collection, the results from the data collection. So as long as the authors actually follow through, do the study that they describe, run the analyses they describe, then however the results come out, the authors are guaranteed acceptance, the journals are committed to publishing it. If the authors deviate from the plan, then all bets are off. So this provides an opportunity for researchers to get feedback on their design, proposed methods, and analyses before they do it, while there's still time to change things. So if the measure is a bad measure, they can be told during peer review at stage 1. So this provides an opportunity to detect and correct errors at a stage when it's most useful, when the study can still be changed. Another important component to catching errors is diversity. And this is because we're going to catch different errors depending on what background assumptions and biases we're bringing to this. This was expressed really well by Naomi Oreskes, who was quoting work by Helen Longino, a philosopher of science. And Oreskes describes this work as saying that the greater the diversity and openness of a community and the stronger its protocols for supporting free and open debate, the greater the degree of objectivity it may be able to achieve, as individual biases and background assumptions are outed, as it were, by the community. So the idea is that if everybody has the same biases and the same background assumptions, we're not going to catch them. But if we're different from each other, we have different past experiences, different backgrounds, we're going to come at research with different assumptions and different biases, and we're going to better be able to catch each other's blind spots. So think about a case where there's a registered report. So an author has an idea for a study, describes it in detail, submits that to a journal, and gets feedback through peer review. Ideally, you would want the peer reviewers and the editors to have different perspectives from each other and from the authors so that they catch different mistakes. If everybody has the same training, the same background, the same expertise, then they're all going to have the same blind spots, and the project won't be as good as it could have been if the team evaluating it and critiquing it had been diverse. So diversity is crucial for critical appraisal to work. Another tool for evaluating the rigor and quality of our work is to check for reproducibility. So reproducibility, the way I'm using it, means can I get the same results if I analyze the exact same data? So I'm not going to go out and collect new data. I'm going to get the author's data, analyze it, see if I get the same results that the authors gave. So it's a very low bar. It's just saying, do your data say what you say that they say? So this is kind of hard to test because often we can't get the author's data, as I mentioned earlier. But there are now more and more journals that require authors to post their data along with their published paper. And so Tom Hardwick and his colleagues actually took advantage of this policy at a journal that had just implemented it, Cognition, and took 35 papers that had been published since this policy went into effect. So the authors were required to post their data. And Hardwick and his team tried to reproduce all of the results published in the paper based on the data that the authors made available. And so what I'm going to show you next are the results of whether Hardwick and his team were able to reproduce exactly the results in the paper. So there's 3 categories. Yes, they were able to reproduce them. 2, the second category is they were able to reproduce them, but only with help from the authors themselves. So they got stuck somewhere and the authors helped and figured it out, and then they were able to reproduce them. And the third category is no, they were not able to reproduce them even after asking the authors for help. So here's what it looks like. Out of the 35 articles that they attempted to reproduce, they were able to reproduce 11 of them without help, another 11 with help, and 13 they were never able to reproduce. And this is in a case where the authors knew that they would have to post their data publicly. So probably the authors of these papers were actually more careful than most authors are to make sure that their results are reproducible. So we can, I think, assume that the world looks even worse for papers where authors aren't required to post their data. That if we were able to get authors' data and try to reproduce their results, we would be able to less than 60% of the time, which is how much they were able to do that here. Another way to catch errors and try to gauge the state of literature is replicability. Try to replicate the work and see how often we're able to get the same result. And here I'm using replicate in the sense of collecting new data. So try to do the same study as close as possible to the original study. Do you get a result consistent with the original? So you've probably heard of many different replication attempts, and part of why we started this credibility revolution in the first place was because of this replication crisis of how much harder it was to replicate published findings than we thought it would be. So next I'm just going to show you a summary of different replication projects across the social sciences. Most of these were attempts to replicate several different studies with very high quality methods. So large sample size, pre-registered replication, and a commitment to publish the replication results regardless of which way they came out. So this is a relatively high quality relatively less biased set of replication results because it had these best practices. So across these various replication projects that are across different social sciences, the overall replication rate, the overall success was that 92 of the attempts were successful out of 199 studies that were attempted to be replicated. So that's 46% success rate, not very good, right? We should keep auditing our field and see if we improve in terms of replicability, see if these reforms that we're introducing are helping increase the replicability rate. What the ideal replicability rate is up for discussion, but probably 46% is not ideal. Probably it should be higher than that. So in the next video, we'll talk about some more reforms to encourage more critical appraisal.